Hi, let us continue with our discussions about the curtailments of reinforcement in reinforced concrete design. We will look into some examples demonstrating how the curtailment is done based on the simplified rules which we have discussed in our previous videos. First, let us look at the simply supported beam. The simplified rules for the simply supported beam is demonstrated here. It is applicable when the load is substantially uniformly distributed load. In doing the curtailments leading to the final detailing of the member, these are the considerations. First, we need to make sure it fulfills the minimum bar spacing, allowing the concrete to flow around the reinforcement during the casting. This ensures good quality compactions of the concrete. Also, the reinforcement should be symmetrically arranged, following the common practice in the industry. And then the requirements for the curtailment. Lastly, the dimension should be rounded to the nearest 25 mm. The main reason of this is due to the industrial practices, which still heavily depends on the imperial units, which are inches and feet. However, in educations, normally we use the SI unit. Considering the applications in the industry, we make the dimensions rounded to 25 mm, which is equivalent to 1 inch, for easy conversions into the imperial units. Having this understood, let us try the example. This is the size of the simply supported beam given, 150 x 450 with a length of 3.5 meter. The reinforcement required at the midspan, it will be 4H16. First, we need to work out the minimum spacing. Normal practice, we will require the maximum aggregate size of 20 mm. Given the bar size 16, the shear size 8 mm, and also the concrete cover 35 mm. The minimum spacing, it will be governed by the bar diameter or the aggregate size plus 5 mm or 20 mm. The bigger of these three items here, it will determine the minimum spacing. Substitute 16 into the equations and 20 into the equations. That gives you the minimum bar spacing of 25 mm. Then you're going to test the arrangements of the reinforcement bar without compromising the minimum spacing. 4 units of reinforcement bar in the diameter of 16 mm to be fitted within the beam width of 150. There are 2 potential arrangements of the reinforcement. Of course, the top priority will be given in this arrangement mode, capitalizing the greater effective depth in order to provide a greater resistance in terms of the moment. However, we need to consider whether the spacing between the reinforcement meets the minimum requirement. Based on the calculation just now, the minimum spacing, it will be 25 mm. You can first test with this arrangement. We have concrete cover 35 on both sides, and then 8 mm shear link, and then 4 units of H16 bar, and everything divided by 3 spacing in between. Since it is only 150 mm, the minimum spacing will not pass. Not being able to fulfill the minimum spacing, this arrangement cannot be used. As a result, we're going to stack the reinforcement one over another. As a result of this, there will be a slight reduce in the effective depth, measuring from the centroid of the reinforcement. Normally due to the factor of safety or the additional AS provided over the AS required. These slight reductions in terms of the effective depth will not lead to the moment capacity of the beam being compromised. Now that you know the mid-span reinforcement should look something like this, you're going to check the actual spacing between the reinforcement. 150 minus 35 minus 35 minus 8 mm minus 8 mm minus 16 mm and minus 16 mm. That gives you a spacing of reinforcement of 32 mm. Check the actual spacing against the minimum spacing. The minimum spacing requirement is fulfilled. Next, we're going to work out the reinforcement at the support. Based on the simplified rules here, at a distance of 0.08 times the effective length, you may reduce the amount of reinforcement bar by half. With 4 units of reinforcement bar at the midspan, half of the amount of reinforcement bar it can be reduced to 2 near to the support. Therefore, you may provide 2 units of H16 reinforcement with the curtailment done at 0.08 L from the centroid of the base. Based on the effective length given, which is 3.5 meter, 0.08 times 3.5 meters is actually equals to 280. Taking into the account for the site practices, we round it to the nearest 25 mm. That means the desired length of 280 mm. If being rounded to the nearest 25, it is either 275 or 300. Now you will need to choose between 275 and 300. Now the principles of choosing this curtailment location, it will be on the basis that not compromising the curtailment rules given in the diagram here. If you curtail the reinforcement at 300, it will be somewhere here. And if you curtail the reinforcement at 275, it will be somewhere here. Then you imagine which is more likely to give you a more conservative outcome, whether curtailing here or curtailing here. The result is obvious. More reinforcement bar will be provided if you do the curtailment here. That leads to you the final option, which you will curtail the reinforcement bar at 275 mm from the center of the support. Based on this analysis, given a simply supported beam, which is uniformly distributed load, with a dimensions of 150 times 450 over a length of 3.5 meter, the midspan reinforcement it will be 4H60, whereas to the support, the amount of reinforcement bar may be reduced to 2H60. In terms of the arrangements of the reinforcement bar, it will be something like this at the midspan and something like this at the support. And the curtailment locations, it will be 275 from the center of the support. This example is rather straightforward. In the next video, we're going to talk about some other cases which will result in different considerations. Stay tuned and see you then.